Hi and welcome everyone. In this lecture, I want to go over linear transformations and matrices and see how they're related to each other. As we talked in our last lectures, uh, we said that a linear transformation always involves a matrix. So let's start. First, let's go over matrix addition or subtraction. When you have two matrices the same size, you can add or subtract them. And again, the way you add or subtract every corresponding entry. That's why they have to have the same size. And this is the ijth entry of the subtraction or addition or the subtraction. Is a number between 1 to m. These are number of rows, and j is a number between 1 to m, which are the number of columns. So let's do an example with a couple of transformations. Here we have the first transformation goes from R3 to R2, and same as the second one. So the first transformation, I wrote that here for you. So this is in R3, X, Y, Z, and these are the components of the transformation, which is in R2, same as T2. So it's in R3, and then we have two components in R2. If we write the matrix for the first transformation, again, you have the x's, so we have 3x, 2x here. So we put 3, 2, the y components are -2 and +4. So it's right here, and the z components are 5, z and -3z, so you put 5 and -3. Same as made the transformation number 2 or T2. And then you have 4x, x, so you have 4, 1. You have 7y minus y, you have 7, -1, and you have -2 and 4. So you write the transformation. Now if we add these two transformations, and I can just do that here, you can add the x component and the y component. So, or you can say 3x plus 4x is 7x. -2y plus 7y is 5y. 5z minus 2z is 3z. 2x plus x is 3x. 4y minus y is 3y. And finally, -z plus 4z is going to give you z here. Now we can write the matrix for the addition. So it's again the x components. If I put x, y, z for the addition components. So as you see, we get 7, 3, which is 7x, 3x, 5y, 3y, 5y, 3y, so it's 5, 3, and you have 3 and 1 here. So now if we go ahead and add the two matrices of the transformations, T1 plus T2. So this was the matrix for the first one and the matrix for the second one, as I wrote it here right there. So if we add them, we can just do it here. 4 plus 3 is going to give you 7. Let's check that. So then it's right here. So 3 plus 4 is going to give you 7. -2 plus 7 is 5. 5 minus 2 is 3. And 2 plus 1 is 3. 4 minus 1 is 3. And -3 plus 4 is 1. And as you see, we get the same matrix when we added the transformations without using the matrices, and then came up with the matrix. Next one is matrix multiplications and linear transformations. Let's go over that. Just recall from calculus or pre-calculus, when you see that this is f of g of x, fog is f of g of x. Now let's see how that works in linear transformation. If you have a linear transformation, T1 from Rn to Rk and T2 from RK to RM. And be very careful when you do that. These two have to be the same. I'll show you in an example. When you do T2 row, again, this you can just read it row. It's a Greek letter. Let me do that again. So it's a row. So T1 row T2 goes from Rn to Rm. So it goes from here to here. So now U is a vector in Rn. T1 of U is going to give you V, and that's going to be in Rk. And T2 of that vector V is going to give you W, which is going to be in Rm. So T1 row, T2 row, T1U is just T2 of T1U, which is T2 of V from here, and that's going to give you W. Let's do an example. So we have a transformation. We're going from R3 to R2, and the second one goes from R2 to R4. We first double check these two are the same. So the first transformation is T of X, Y, Z, and that goes in R2. So these are the components. And the second transformation is T of U and V, and that's in R3, that. So T2 row T1 X, Y, Z is T2 of T1 X, Y, Z. So basically, that's going to be your U's, that's going to be your V's, and you just go here and you substitute. So wherever you see U, you can substitute that, and wherever you see V, then you can substitute this one. And these are components, not vectors. So see how that works. So here we have X U plus 2V, so it's just going to be X minus Y plus 2Z plus 2 times, and that's our V. Here we have 5U, so 5 times that, I wrote it here, minus V. Minus V, you can use a parenthesis, so it's minus that, and plus 3U, so it's going to be, it's a comma here. So it's 3U is going to be 3 times X minus Y plus 2Z. And finally, the last one is U plus V is that plus that. So what we get here, if you open the parentheses, get rid of the parentheses and combine right terms, let's just do one of them, X plus 5 plus 2 times 3x is going to give you 6x plus x with 7x, and so on. You can combine the y's and you can combine the z's, and that's what you get. So if you write the matrix for this one, so we have again x, y, z. So for x, we have 7, 2, 3, and 4, 7, 2, 3, and 4. For y, we have 1, -6, -3, and 0. So this one doesn't have a y. And for z, again, this one doesn't have a z, so it's 0. Then we have 11z, so it's 11 here. Then we have 6z, so it's 6 here. And we have 1z here, which is 1. Now we can write the matrices separately. So again, for the second transformation here, you can say U, V, and the first transformation is X, Y, Z. So you can one by one write the matrices for the first and second transformation here. So for the second one, we have U, 5U, 3U, and U. So let's look at this, 1, 5, 3, and 1. And for V, we have 2V, -V. Here doesn't have a V, and we have V, so it should be 2, negative 1, 0, and 1. Let's check 2, negative 1, 0, and 1. You can write the same for T2. And notice what we are doing here is T1 row T2, not T2 row T1, not T1 row T2. Now, if you multiply those two matrices, the one we just found, this was for T1, and this one was for T2, and this one was for T1. If we multiply them, so 1 times 1 is 1, plus 2 times 3 is 6, so the answer is 7, and so on. 1 times negative 1 is negative 1, 2 times 1 is 2, so 2 minus 1 is 1, 1 times 2 is 2, and 2 times negative 1 is 0, so you get 0 here, and you can write the matrix right here. Let's see. So when we did the composition of transformations, we got this matrix, and when we wrote the composition here, and when we multiply two matrices, so we do get the same answer. So this is for matrix multiplication. Now let's talk about the inverse of a matrix. That has to be a square matrix. So let's do an example. When we go from R2 to R2, this is our transformation. So if I write T, I get 3, 2 for X components, 3, 2, 7, 6 for Y components. You can find the inverse of this matrix by using the formula for a 2 by 2 matrix and to find the inverse, and that's what you get. Now if you write the transformation for the inverse, so let's go ahead and do that. So we have for the inverse here, we have 3 over 2, and that should be 3 over 2x minus 7 over 4y, and then we have negative 1 over 2x, and then plus 3 over 4y. It's right here, and that's just 3 over 2. If you do T inverse rho T, like in calculus, when we did f of f inverse, you get x here. If you do the same thing, so if you substitute, so you go to your inverse transformation, and wherever you see x, you can multiply, but you can substitute that, and wherever you see y, you can substitute that one. And if you do that, or vice versa, substitute and you combine like terms, get rid of the parentheses and combine like terms, you'll see you're going to get x, y. And so if we write the matrix for this one, it's just going to be I2. So for x, we have, if I write the matrix for this one, let's do that right now. So for x, we have 1, and for the second x, we have 0, and for y, we have 0, and we have 1. So that's basically what happens. So every transformation has a matrix, and you can basically use addition, subtraction, or multiplication of the matrices, and you'll see that if you do the inverse, you can find the inverse of the matrix, write the inverse of the matrix, and when you do write the transformation of the inverse matrix, and if you do T inverse rho T or T rho T inverse, then you're going to get X, Y, and that's just the identity matrix. I think that's it for this video, and please watch this couple of times. These are pretty easy. you watch this couple of times, try some more examples on your own, and I'll see you in my next video. Have a good one, everyone.